The final topic is economic life versus physical life. And here's where we have a piece of equipment, let's say, and we're using it, and all the time we're using it is generating cash flow. However, the project itself has a salvage value. So we're saying, when should we retire the asset? So we're going to look at cash flows. So this is a new scenario with years 0, 1, 2, 3. Year 0 is the outlay initially of $5,000, and that's what the project or the equipment costs us. At year 1, it generates a good amount of money, $2,100. Next year, $2,000. Final year, $1,750. But notice that the salvage value, as you would expect, would decline as it gets older and older, from $5,000 to $3,100 to $2,000 down to 0 at the end of year 3. So now we're going to subject this to a little bit more scrutiny and analysis using net present values. So what we see is that we have some scenarios. So we have a scenario where we hold it for 1 year, and let's do the cash flows. So the cash flows for year 1 would look like this. We have to pay for it and get 1 year, and then at the end of year 1 we get money. We sell it and get $3,100. So the cash flows would be $5,000 for year 1 and $5,200 for year 2. So equals NPV, discount rate of 10%, comma, and it was plus 5,000. So 273 is the negative in this case, cash outlay. So let's do 2 years. So 2 years is we get these 3 specific numbers, copy that, row, and then notice that we're now out here. How much money will we get here? $2,000. So plus that, copy that, and we could do the NPV equals NPV and rate, still the 10%, comma, years 1 and 2, close friends, plus the outlay, and we're now 215 positive, right? So that's a better proposition so far. And let's say we hold it for 3 years. So we'll get all 3 years of cash flows. And we get a salvage value equal to 0. And so the cash flows are as follows, and we can do the NPV equals NPV, rate is 10%, comma, cash flows, and outlay, keep it outside, and it's negative 123. So here we see that even though we could see this normal pattern of declining value for a piece of equipment, there's a clear advantage to selling it in year 2 because we would actually maximize our cash flow. So we get 2 years worth of value from it. We get to recoup a fair amount of salvage value of $2,000 and get rid of it before it becomes useless. So that's an example of economic life. The economic life of this particular machine is 2 years, whereas the physical life may be 3. So summarizing this chapter, we looked at the basics of budgeting, like when it occurs and why. We looked at many methods of evaluating projects, strictly cash basis, just adding the numbers, a little bit more sophisticated using time value of money with NPV, using alternatives but quite commonly used metrics like IRR and MIRR. Then the other is using a blend of a NPV and kind of a simple notion of using profitability index. Then we look at a very commonly used method called payback method, which doesn't consider time value of money at all. And we also refined it a bit to make it a discounted payback period, which I consider a bit of a waste of time. I like payback, just do it for a quick and dirty estimate. Then after you're done with that, it looks pretty good, then subject it to more rigor and do NPV. And if you have to explain it to non-financial people, then use IRR so they can understand it. I mean, that's probably a practical way to think about this. Next, we looked at some variations. One is what happens if the projects have unequal lives. And we looked at 2 methods. One is the equivalent annual annuity approach, where we pick the higher number. And the second is where we could chain together, called replacement chain approach, the one of the shorter lifespan so that we can make the time spans for the 2 projects comparable. And finally, we look at the economic life of an asset versus its physical life, and found that sometimes the economic life has high value prior to the the expiration of the physical life. So that's it for this chapter, and I will see you guys in class. Thank you. Bye-bye.